All right, let's do it. Rectangular, put it into polar. Review. Polar, r, comma, theta. R got to be positive. Theta has to be positive and in radians. Let's go over the process of how to turn these into a polar coordinate. Everyone do a quick sketch of where negative 4, 4 should be. Quick sketch. All right, quick sketch. What quadrant are you plotting that point in? Quadrant 2, yes. So please draw a triangle, an appropriate right triangle in quadrant 2. If you forgot how to do the triangles, draw your bow tie out. On the x-axis, this should be, what was my x-coordinate? It was negative 4, but again, you're talking side lengths of a triangle. Never negative. So I know it says negative 4, but we always put the positive versions because we're talking about side lengths. And the same thing goes for the y value, positive 4. So I got 4 and 4 here. Where is your r value located? The hypotenuse. Right here. There's your r value in the polar coordinate. And how do you get to that r value? Pythagorean theorem. Let's roll. 4 squared plus 4 squared is equal to r squared. And yes, if it can be broken down, break it down, the radical. Simplify the radical if it can be broken down. Bless you. So go ahead, break down the square root of 32. This is a little bit of a tougher one. Oh boy, it's been a while since we broke down the radicals. I'm looking at some of your papers and hearing some of you talk. What's the biggest perfect square that goes in the 32? 16 goes in the 32. And what is the square root of 16? 4 radical 2. Okay, there's your r value. There's the r value. How do I find theta now? The angle in the second quadrant. How do I find theta? Anybody remember what I used? Tangent. Here we go. Tangent. Opposite. Now, it doesn't matter here because the numbers are the same, but it will matter once you go to number 11 and 12 when the numbers are different. Opposite side over the adjacent. Opposite side over the adjacent. 4 over 4. What are you guys pressing on your calculators now? Inverse tangent. Yep, go. Inverse tangent. Grab a calculator if you need it. Inverse tangent. And you end up with 45 degrees, right? But again, theta's got to be in radians. What's 45 in radians? Pi over 3 is 60. Pi over 3 is 60. Pi over 6 is 30. 45 is pi over 4. And this part drives me nuts. That's not the darn angle I'm looking for. What did you just find? The reference angle right here. I need the angle in the second quadrant, not the reference angle. So let's think through this because we had a tough time with this. What is the degree measure or what's the radian measure from here to here? Pi. At 180, right? Pi. What do I have to do with that and my reference angle to get the angle in the second quadrant? Right here, do I have to back up or do I have to add on? Back up, so I'm going to have to subtract. Pi minus pi over 4. What's the pi turning into so I have like denominators? 4 pi over 4. So what is my new angle theta? 3 pi over 4. So the polar coordinate, 4 radical 2, comma 3 pi over 4. Let's go through each quadrant right now. What if your triangle was in quadrant 3? What would I have ended up doing to these two? If my triangle was in quadrant 3 now, I'd add the two. What would happen if the triangle was in quadrant 4? I wouldn't use pi. 2 pi minus the reference angle. And finally, trick question, what if it's in 1? It's the reference angle. Okay, if it's in 1, you use the reference angle. Everyone all good? Next, part number 13. What if your point's on the line? Go ahead. 13. Sketch 0, -5 for me real quick. Where's 0, -5? Right here? Okay, if it's on the line, no triangle should be drawn. Your R value is the distance from the origin to your point. What's that distance right there? Distance, so I shouldn't hear a negative number come out of your mouth. Distance, 5. And what about the angle now? What is that angle right here? We've been in there all year. It is 270, but remember it's got to be in radians though. 270 is the same as what in radians? 3 pi over 2. Hey, you blank on it. Big deal. What could you multiply 270 by to get into the radians? Pi over. Okay. So even if you blank, no excuse. Questions there? So we okay there? I'm going to let you finish those on your own in a second. Yeah. 16. Rectangular to polar. Hey, meaning if you're going to change it into polar, I should see R's and I should see thetas rolling. Not X's and Y's anymore, R's and thetas rolling around. And it's solve for R. So at the end, I should have R equals something every time I put it into polar equation. 16, anybody remember a little substitution for X? R, here we go, everyone. R cosine theta all squared. What about your substitution for Y? R sine theta all squared equals 100. What do I square inside here? What gets squared? The R gets squared and the cosine gets squared. The R gets squared, the sine gets squared. See anything in common on the left and right side of the plus sign? I can take out a R squared. Yep, let's go. R squared. And then another one you should go into tomorrow knowing, cosine squared plus sine squared is just 1. Yep, so R squared equals 100. Again, the goal when you put it into polar is to have R by itself. So R equals 10. Now, I don't know if anybody was thinking this at all. Somebody brought this up third period. X squared plus Y squared was the same, was what we've been dealing with? R squared. So if right away, if you wanted to substitute in R squared equals 100, you could. All right, I just wanted to show this way to remind you guys how to factor, and sine squared plus cosine squared is 1. All good there? I got one more for you. Number 21. Now put it into rectangular. So give me X's and Y's now. X's and Y's. I have R, number 21, everyone. I have R equals 3 cosine theta. I do not have any substitution for R. What do I have a substitution for, though? R squared, right? So multiply. Now, does it make, I can get R squared one of two ways. Does it make sense to square both sides? because I have no idea what to do with this. But what's the other method to get r squared? Multiply both sides by r. Because now look what you get on the right side. 3, r cosine theta. I believe that sounds familiar. R cosine theta is the same as, yep. And what about, I need to get that r squared out of there, though. That's not going to fly. We'll put it in a rectangular. X squared plus y squared. So anything in polar needs to be solved for r. Anything in rectangular needs to have an x and a y's in them. Questions? Yep. Yes, tomorrow. Yep. Secant, remember, is 1 over cosine. Cosecant, 1 over sine. That's it. Okay. Anything else? Okay. If you got your Chromebooks out, get them out because the answer key is up on Aspen under the polar folder. All right. That's what you're doing. I don't need to see it. All right, but get going. You got finish up through number 22. You are done after number 22.